Okay, so I'm in this little video, so if anybody's ever absent, like myself or others, you can still have something to listen to over the weekend about how to do these areas of certain things. So area of a parallelogram. We need to remember that parallelograms are these things that have parallel lines. So that's one arrow so that you can see they're parallel. Now in that, you're going to have a height that drops down here. You're also going to have a base that's this long. Right? So it doesn't matter which side it's facing, you're going to have a figure like that. Now, what you're going to want is the area for parallelograms is going to be base times height. One thing to note is they might draw the figure like this and then put in this height out here. Now remember, whatever you use for the height has to be straight up and straight down and make this perpendicular in the corner that I was trying to cover up there. Now this is still your base from here to here, wherever that point stops. So make sure you have something like that. Area of a triangle. So if I were to draw a triangle in here, alright, you would have a base here. You'd have this distance for your base. And you'd have a height in here that came down and was perpendicular. So like triangles, it is still base times height divided by 2. And we've done a lot of those now. These also can be drawn this way. What you would use if it was drawn this way is this height on the outside and this base that goes from here to here. And the height would go all the way to the top. Excuse me. So, one other thing to note before I get too much farther is label for area is always equal to units squared. So if you come across an area problem and a couple of the answers don't have units squared, you could probably scribble those answers out as bad answers because you're not going to use those. Right, so you can pause, draw the pictures, but I'm going to start erasing here and move on to trapezoids, rhombuses, and kites. So trapezoids are a little bit different because trapezoids, remember, have two bases. They have this base 1 here that we call it, and then they have a base 2 on top. Now, like the other figures, you have to use the height that's giving as a perpendicular there. And then for trapezoid, the area is just height times the bases added together, divide by 2. And I told you the label for all of these is the same thing. Now rhombuses and kites are together here because rhombuses and kites both are area is equal to diagonal 1 times diagonal 2 divided by 2. So if I drew a kite over here, right, a lot of the ways you'll see the kites drawn is they'll do this thing. They'll give you a distance out here, and they'll say this is one distance, then they'll give you the other one down here and say this is the second. The other possibility, which they do in rhombuses more frequently, is they do this thing, right? But then what you're supposed to know is if this is 7 down here, you need 7. So you need to use a distance 1 of 14 where you added them together. And this might just be 6 and 6. Alright, so then you'd have a distance 2 of 12. So make sure you're checking those distances for diagonals so that you can use them appropriately in our diagonal 1 times diagonal 2 divided by 2 for areas of a trapezoid. Or areas of a rhombus and kite. Trapezoids up above. So I'm going to get rid of these. So you should pause and make sure you have all this down. So this is even going to be more boring than normal class because I don't have any bad jokes to tell. So up here we have areas of circles and sectors of circles. So what that means is we have a circle. This is our radius. Alright, and we would have area of a circle to be equal to pi r squared. and R still stands for the radius. Now, if we want a little piece of the circle, so what we say is maybe this blue is shaded in. This is our sector. Alright, so that's a little piece. So how we do that is going back to our little X here. So I'm trying to get a green X in here. So X degrees. So it's kind of like our arc length formula. Our sector formula is going to be the area of the sector is going to equal that X over 360 degrees pi R squared. Right? And then the X is going to stand for the degrees of the shaded region. Make sure it's the shaded. Sometimes they'll give you the unshaded and make you subtract it from 360. So that's what you got for areas of circles and area of sectors. For area of regular polygons, that's these hexagon things that I taught you to break into triangles. Reason we did that is we know area of a triangle is equal to base times height divided by 2. So if we have 6 triangles, 3, 4, 5, 6, right, what we can do is the area of a regular polygon, or the area of a hexagon, is going to equal 6 of those area of triangles. And then remember, you're just trying to find the base times height divided by 2 thing. So if I wanted the area of a pentagon, I would have 5 triangles, but I'd have to multiply, find one area and multiply it by 5. Composite figures. So if I look at composite figures, what I'm looking for is a lot of math. So if I looked at this, I would have this, 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 this. Right? Cut this in half. So you can cut things in half and use what you know to solve this for a composite figure. So to me, this stuff right here would be a trapezoid, and this one right here would be a parallelogram, or also known as a rectangle. So the area of a rectangle is the same as a parallelogram. It's base times height. So if I look at this closely, it would probably be my base, and my height would be 12. So I would probably go this as 8 times 12, which is equal to 96 units squared. And then if I looked at this trapezoid, I'd have 7, 5, and 12. So area of a trapezoid, I'll review, is equal to height, base 1 plus base 2, divided by 2. So then the area of the trapezoid, I would have said it's turned on its side, so I would have said the height 7, making me have to add the 12 and the 5 together and divide it by 2. So the area of the trapezoid, if you do that correctly in a calculator, is 59.5 units squared. So the area of this composite figure, the area of the composite figure, which I'm writing in black here, would be 96, and you can just add the 56.5. So this composite figure would be 155 units squared. Okay, so that's the bottom of that page. So then we got to do one more area one. And we'll have to erase, so you should have paused this now. So that's a good example. You could use that example to solve some of them that you're going to work on your worksheets with, and other things. Now, irregular figures and similar figures. So irregular figures was when we would take a grid. Oops, that's not on your sheet. Hold down. is when we would take this grid and we'd have these lines in it, and then we'd draw a little lake in it. Alright? That's what we're talking about. This is an irregular region. Now, what we told you to do is A, count full squares. B, count partial squares. Alright? And that means we need to divide that number by 2. Alright, so we're going to divide that number by 2. Alright, pause. Let's figure out what's going on.